Hello, my name is Jian Kim, and I am today's TA. So today we'll be having a lab session on scikit-learn. And today's practice topics are data plotting, generating samples, regression. We're going to work on linear regression and polynomial regression, and data loading and classification. So when using scikit-learn, it's important to use the scikit-learn documentations. So I will be switching now and then to the scikit-learn documentations to show you how you can use it. And first of all, you need to make sure to change your runtime type to Python 3 CPU. Today, we won't be using any GPUs, so you can just use CPU. And so first of all, you need to import all the packages that we need today. We're going to use NumPy, Matplotlib, and scikit-learn. Matplotlib is a library that we frequently use to visualize our data results. And you can run the code to import the libraries. This is a Matplotlib example, and we can use this plot function to plot the data into a line. So the coordinates are 1, 3, 2, 2, and 3, 1. And for this scatter function, we can plot these dots. So if we run the code, it would show like this. And so this plot function plots this line, and the scatter plot function plots the dots. Here we have this draw plot function, which takes x and y and x sample, y sample. And what it does is it plots x and y. So for the given inputs x and y, it would plot all the lines in x and y. And using x sample, y sample, it's plotted using this scatter function. And we'll be using this draw plot function now and then. So you can run this code. And now for drawing a function, we have this function defined as foo, and we're going to generate some data and do some visualization in this code cell. So first, you need to generate data using linspace. And what this does is, this is starting from 0 to 10, we would generate 100 data samples that are evenly distributed. So you can try printing X line. It shows 100 samples starting from 0 to 10. Now, this is a mini quiz. You won't be scored, but just for fun, you can try drawing the function foo using X line. So it's a very simple question. You can put X line as input and draw Y line. And you can try plotting it. So this is our X-line, Y-line plot generated from foo. Now, this is another quiz, mini quiz. You won't be graded. In today's session, there won't be any graded quizzes, so all the quizzes are just for fun. You can try sampling 5 points of foo in the domain 0 to 10 and visualize it with the draw plot function here. Yeah, I'm seeing a lot of comments. So first, we can generate 5 points using NP random uniform. From 0 to 10, 5 points. And using this example, we can generate the output of foo. And then in order to visualize, we can use draw plot. So we need to visualize X line, Y line, and X sample, Y sample. So for the lines, we define it in a list, and here it shows the X line, Y line that we saw here. And these are the X sample, Y samples that are generated. And every time you run the code, you can see that the data samples are always different. And this is actually because we didn't set the seed. So if we set a seed to a fixed value, for example, 200, then whenever you run this code, you will always see the same data. So this is fixing the random seed is used for reproducibility. And this is another mini quiz. You need to sample 5 points of foo in the domain 0 to 10 and add Gaussian noise where mu is 0, sigma is 1, and visualize. So you guys can try. To give you a hint, for Gaussian noise, you need to use NP random normal. And you can define the mu and sigma here. I'm seeing a lot of comments. So set the sample size to 5. And create X sample from linspace. You can actually sample from something else, but I'll just use linspace here. And we need to generate the foo output using example. And we need to add Gaussian noise here with nu 0, sigma 1. And then we want to visualize. So I'm gonna again use draw plot. So I'm gonna plot this X sample, Y sample on X line, Y line. So I'll just comment out this for a while. And yeah, here's the output. So we added some Gaussian noise. We can see that the dots are not exactly on the X line, Y line. So this is because of the noise. And if we increase the scale, it would be more farther apart. Do you guys have any questions? I'm seeing a lot of comments on codes. Raw plot with code. Oh, it actually shows the plot here. I've run the draw plot function and plot.show shows this plot. Okay. The one above it. Do you mean this one? It shows the plots. Part 4. Do you mean this function? Yeah. If you run this draw plot, it would always plot plot here. Oh, okay. So plot.show here doesn't show anything because it's within a function. So it would only show when you call this draw plot function. Yes, we do need it because the X and Y here is used like this. Okay. And now I'll move on to linear regression. So we can use linear regression in scikit-learn. First of all, we need to define a linear regression model. And scikit-learn linear regression. You need to use these docs whenever you're implementing this code. And this would create a model instance, and using this fit function, it fits the linear model with the training data. And we can't directly put an example as input here because the X should be a matrix type. That's why we expand X sample into a matrix. So if we try printing X sample, it would show like this. And if we print X sample, it would print a matrix, and we need to use this. So we fit the X sample matrix type data to the Y sample data and train this model. And then for coefficient of determination, you can use score here. So this is the documentations. It returns the coefficient of determination of the prediction, and this is what it is. So if you run this code, it generates the result of R2. Now, if we want to predict the data points, we can use predict function. So this also takes a matrix type as input, and we can store it in Y hat. Now, this is a mini quiz. Calculate the mean squared error using X sample, Y sample, and LR predict. So you guys can try implementing it. We can just use the MSE equation. And try printing MSE. This is the result. And use Xline LR predict and draw plot to visualize the linear regression model in comparison to the original function foo. So you need to generate a Y prediction using Xline and compare it with Y line here, because this is the foo output of Xline. So LR predict Xline for predicting Xline using this LR model and draw plot. We want to compare it with the foo output. So this would be the result. This is the original plot that we saw above. It's X line, Y line with X sample, Y sample plotted here. And there's also Y pred line, which is this linear regression output. Now we'll move on to polynomial regression. So unlike the linear regression class here, we can't directly, there isn't any class we can take for polynomial regression. So we need to first use polynomial features and then use linear regression to generate the output of polynomial regression. So it requires 2 steps. And first of all, I would generate polynomial features with degree 2 and transform the original features to polynomial features. I would input X sample in a matrix form. You can use fit transform here. Polynomial features. You can use fit transform. This is the transformed output of X sample. And then we need to input this polynomial feature output into a linear regression model to train. So this is our trained model. And there are 2 mini quizzes that you can do for fun. Visualize the polynomial regression model in comparison with Foo. So it's similar to this. You guys can try implementing. So first of all, you need to input X line and generate polynomial features with X line. And this should also be done in a matrix format. So using this instance, we would transform X line data into X polyline. And then we want to use, okay, I'll just define this as PR. We're gonna use this polyline and put it through this PR, trained PR. And in order to do this, we're gonna use a function called predict. Yeah, I think we already done it above. lr.predict. There's this predict function. It's polyline. Store it into ER line. And then, so this is the output for X line polynomial regression. And we're gonna use draw plot to visualize it. So I'm gonna plot these X sample, Y sample, and this line here. together with this PR line. So Y line, Y pred line. This Y, okay, Y pred line and X sample, Y sample. So this is our plot. We have our linear regression model here, the original X line, Y line, and this is our polynomial regression output. And then if we increase the degree, so starting from degree 2, we can subsequently increase the degree. You can see that the line is fit by the dots. Here you can see the degree is 2 and it's kind of underfitted. If we increase to 4, yes, this looks similar to degree 3, and degree 6, it's overfitted. So we can see underfitting, overfitting here as the degree increases. Now we're gonna move on to loading our data, and we're gonna split it into train test. Then we're gonna define some classifiers and train it for classification. So this iris dataset, I'm sure that a lot of you would be familiar. It's a multi-class dataset, which has 3 classes as the labels. So these are the Y classes, and if we try loading the dataset and showing X shape, Y shape, you can see that the Y is the labels, the class labels, and X is 150,4, where 150 is the count of the samples and 4 are the number of features. So the features consist of these 4 things. You can kind of think of this as tabular form data. And then we want to split the train and test. And in order to do that, you can use train test split. So input X and Y, and you can define the ratio for the train test split. Here I would use 8:2, and you can use 6:4 or something else. You can just modify this test size ratio here. And the random state is, this is for reproducibility. So whenever you run this code, you want to make sure that the train test data is always splitted with the same. So the train data is always the same and the test data is always the same. And this random state does that for you. So I've splitted my train test data 8:2. And now I'm gonna try defining classifiers first using logistic regression. And we've done this before. We can set a random state to 1, 2, 3, 4, and we can fit this model with X trained data and Y trained data. So you can try printing the scores. Using test data. It's 0.733. And here I am only using 2 features because if I try using all the features, it's too easy and it generates a score of 1. So that's why I am only using 2 features here to make the task a little bit more difficult. And you guys can try implementing SVM and decision tree. There are a lot of comments, so it's really difficult for me to filter out the questions. I think they're mostly code. So maybe you guys can try SVM decision tree, and if you're done, you can upload it in the chat box. This is also not scored. Yeah, I see some answers. We're gonna have to use SVC. And for the regularization, you can define parameters based on this documentation. I'm just gonna use three to three. And again, if you want to train it, you need to use this fit function. Fit the model using training data. And so I am only using 2 features here for training for the train data, and I'm fitting it to this model instance. So this is the training procedure. And I want to also show the scores. So this shows the accuracy of test data and labels. I'm going to use this score function. And test it on test data. Okay, so this SBC results in 0.732. And you guys can try the decision tree. It's very similar to SVM and logistic regression implementation wise. So decision tree classifier. There is this that you can use. Here are the parameters, attributes, and some examples. And you can use the methods below to train and get scores or get the predicted results. So I would import decision tree classifier. And then create an instance. What do I need to define? A max step. And I would set a random state. You can set a max step to something else. And then, so this is the DTC instance, and I would want to train it on my train data. We're going to use the same fit function here too, and use two features from xtrain. And then I'm going to use this score function to test the data. And so using decision tree, you get 0.56. Okay. Do you guys have any questions until here? Okay. So use the model's predict to calculate the test accuracy. Yes, random state parameter is like a random seed. So we can use this predict function to generate the predicted results of X test. And above here, actually, we already calculated the scores of X test on this Y label data. So if you get import errors, you should try to import scikit-learn again. And use various model options, features, and score function to compare performance. You can do this for fun. And then this is our last question here. You can draw 4 scatter plots for each model's prediction and the true labels. So based on the skeleton code, draw 4 scatter plots. So to get the model's prediction, you can use the predict function for logistic regression, SVC, and DT. It is this function which generates the predicted output. So whenever using scikit-learn, you need to look at what functions you should use, and you should make sure to put in input data type that matches the documentations. So for example, X, this requires a matrix, so you should input data that is in a type of a matrix. And for Y, you can use either this or this. And for the predictions, I'm going to use. So we've already trained this logistic model with this fit function. So we're going to predict it using test data. And also for SVC, we can use this predict function. And for the decision tree, we can also use the prediction function. So these are the predictions. And if we print it out, we can print out these 3, comment out the rest. And it would show the predicted results. I am seeing a lot of comments on people uploading their codes. So we need to use scatterplot, and we're going to use Matplotlib, which we imported in the start of our class. We're going to use this scatterplot here. So for visualization, you would really frequently use this library. And X, Y, you would input the input data, and for C, the colors. So what we want to do here is we want to see how the data points are classified with, and we're gonna visualize it with three different colors. So because we only used the first two features of X, and we're gonna use the first two features as input. And for C, this is the array-like or list of colors. So we have these class outputs as our prediction, and we're gonna input it in the C parameter. So for logistic regression, you can see this visualization over here, which classifies with three different colors. And you can use the same for SVM, decision tree, and ground truth by just modifying this C parameter. With ground truth as Y test. And this plot.show shows the 4 plots. So this is the ground truth, the classification, and these are the results for logistic regression, SVM, and decision tree. So today's session is very straightforward. Do you guys have any questions? Yes, we will upload the solution file. So was today's session too fast or too slow? I mean, there are like more than 300 people, so it's difficult to kind of, I don't know, set the speed. No, we will not be taking attendance. I've got a direct message from someone. So, okay, the speeds. Okay, so for some people it was too fast, some people it was okay, some parts were slow. Okay, I will slow down next week. I'm sorry. Okay. So maybe I'll go through a little quick recap. Today we did data plotting and generating samples, regression, linear regression, polynomial regression, and data loading using the iris dataset, and classification with the iris dataset. So we imported NumPy, Matplotlib, scikit-learn, and we can use this plot function to plot the line and plot the dots for the scatter function. And then for this draw plot function, it plots X and Y using this plot function. So we can input on a list here, and it would plot all the X's and Y's with this plot function. And X sample, Y sample is also plotted. So if we put some coordinates here, it would be plotted using the scatter function. And then for drawing the function, we first generate samples using linspace and the outputs using foo, the function here. And then we sample 5 points using NP uniform. So from 0 to 10, we sample 5 points. And then using this outputted X sample, we put it into the foo function and get Y sample. And then for this quiz, we generate X sample, Y sample using linspace and add Gaussian noise using NP normal. So this is the plot that's drawn using draw plot. And then I'm going over the same thing just for recap. So if there's anyone who already got this all done, then you can leave. For linear regression, for NP random R samples, I'm half open. Okay. You can actually check the documentations and less than equal to high. Okay, why do we use C as Y logistic on plot scatter? Because we want to identify different colors, and we can use, so this Y logistic, this prediction result shows the predicted 3 classes, and it would map to different colors using the index of the classes. So that's why same classes would have the same colors and different classes would have this different colors. So that's why we can just use the predicted classes for this C parameter. And then going back to the review, for linear regression, we just define an instance, and we use this fit function to train the X sample data. It's training the model, LR. And then this is the score function here is used for coefficient of determination. And we can predict the data points using X sample here. So this is the predicted y hat. And using y hat, y sample, we implement this function, MSE function, to get MSE loss, which results here. And then we use LR predict, this predict function, to predict the X line on the LR model that we trained. And this orange line is the draw plot for Y-pred line, this linear regression curve. And then for polynomial regression, we define an instance, polynomial features. So we use two steps, first defining polynomial features, and then we transform the original features using X sample. So we use poly to transform the original features. And then we train a linear regression because we ultimately want to do polynomial regression. And we take this X sample poly and fit it to the linear regression model. And we get a PR, which is polynomial regression. So in order to use X line and perform polynomial regression, we first need to transform it into polynomial features, similar to this step here. And then we already trained a model, a polynomial regression model with X sample poly. So we are going to take this trained model and use it to predict X polyline. And then the draw plots. For draw plot, we can plot this green function. And as the degree increases, it overfits. So this is because it's getting more complex. And then we want to load the iris dataset, which consists of 4 columns and 150 rows with 150 labels. We split it with train test split, and we can define the split ratio using test size. And random state would always generate the same train test data. So for classifiers, we worked on logistic regression, SVC, decision tree classifier, and basically we would define an instance, and then we would train it by using this function fit. We would train it with the train data, and so if we only want to use 2 columns, since the X shape is 150 to 4, we need to only use column 0 and 1. And we do this by this method. And then in order to predict the model with test data, we use this predict function, which generates this predicted output using SVC. And then for plotting, there are many different plots other than scatter plots in Matplotlib. So you can try using other plots when dealing with different types of tasks or different types of data. So first of all, we get our predicted results, and we store them in these 3 variables. So these trained models generate a predicted result using the test data, the first two columns of test data. This is because we only trained it on the first two columns of trained data. And then the scatter plot here shows the classification results. Okay. So this was a short overview of what we've done. Do you have any final questions? Maybe I'll be waiting like 30 more seconds. Okay, great. I'm happy that it helped. So we'll be posting the solutions on Classroom. You guys can review it, and yeah, please get used to using the scikit-learn documentations. And also for Matplotlib, you would also have to use the documentations to generate the results that you want. Okay, so if you guys don't have any more questions, I'll be ending the session here, and we'll be having another lab session next Thursday. Thank you. Bye. See you next week.